Okay, so hello everyone. Very good afternoon to you all. Today we are here in the third live session of the NPTEL session, NPTEL course Automation in Manufacturing. I am Sohit Anand Singh, pursuing PhD in the Department of Mechanical Engineering, Indian Institute of Technology, Jodhpur. I am a Prime Minister's Research Fellow, and through PMRF NPTEL TA scheme, I got this opportunity to get interacted with you during this live session. We are here to discuss few problems that are related to the course, and then uh, uh, to solve your queries or any problem that you are facing while uh, pursuing this course. So this is a third session. This is a third live session, which will be focusing on the course content that is posted for week 3. So I hope you all have gone through the course content, and some of you or most of you have been uh, completed the week 3 course module, and maybe solving your assignments. So you may have faced some problem, so we will discuss it here. So as per our earlier sessions, this session again I am dividing this session into 3 parts. So in the first part I will be discussing the questions that I have made for you, that will be again just to brush up your knowledge and what you have uh, studied in week 3. Then in second part, I will be taking the questions from the discussion forum that some of you have posted in the discussion forum. I will be discussing those questions. And then in the last session, in the last section of this session, we'll be uh, interacting with you, and you will be allowed to ask questions, and I will be answering your queries. And if there is an issue in during this course, I will be discussing all those problems live here. So let's begin with the first module of this session. So it is like multiple choice question. The first question is on your screen. I want the participation from your side, so that this session will be more interactive and more fruitful. The first question is a very basic question, that the simple definition I'm asking to you. The question is on the screen. I read the question. The probability that a product, system, or a service will perform its intended function adequately for a specified period of time, or will operate in a definite environment without failure, is called. So
Reliability, sir.
answer is reliability. Okay, Rajesh is saying reliability, and then I'm seeing, okay, 3. Okay, D, Sudeep, Chaitanya. Okay, D. Yeah. So the answer is definitely it is D. It's a simple definition. So it's the reliability, which is a probability of any product or system or a service that shows that it will perform for a specified period of time, or in a in a defined environment without failure. Okay, so moving towards next question. The second question is on your screen. The question is again, it's from the from the course slide. So it is directly from the course slide. Nothing has been changed. I've just took it from there. So it is in the context of selection of component for an automated system. The effects due to radiation is an example of which factor? So when you are going to select the component for making any automated system, so there are several factors that you have to keep into your mind. So there's a effect if the system has an effect of radiation. So that effect of radiation is is an example of which type of factor? Option A is system, B is climate, environmental, or civil. Okay, so I got the answer also. Okay, lots of people have answered here C. Yes, so it is a radiation is a environmental factor. I hope there is no confusion in these questions. These are very simple questions. Now, third question is on the screen. The question says the ability of the sensor to indicate the same output over a period of time for a constant input is called. Again, it is a definition. And if you have read the course content, then you must be able to answer this question. So Amritpal Singh said C, D. Okay.
Stability.
Rajesh is saying stability. Okay. Sudeep Chaudhary saying B, resolution. Okay, so it means this definition has some confuse. Okay, C, yes. So yeah, it is a very, it is not a very difficult statement. So the statement is like the ability of a sensor to indicate the same output. So if you are using some sensor to measure some value or some data, so if it is giving same output for a long period of time, and by applying same or constant input, so this property of a sensor is known as its stability. It shows that the sensor that you are using is a stable in nature. Okay, so it is stability. Okay, so now fourth question is, so yeah, here I just wanted to throw a knowledge, some light on this error. Other, resolution and impedance is something electrical property that is not of this contest. So resolution, error, and stability is here. Resolution I will be discussing in subsequent slide. And error, so error is what is error? Can somebody define me what is error?
Difference between the measured value and true value.
Yes. So difference, the error is like, suppose you are having a instrument that you are using for measurement of some quantity. Okay. So suppose if you have made your own scale. Okay, and you are measuring some distance or some length. Okay, so how you will find that your measurement is accurate, or your measuring instrument is accurate or not? So you have to find the error, like what is the percentage of error it is showing. So for getting that error, so what we'll do, we'll measure with our own that instrument that you have made, and with some standard, or with some standard instrument, or maybe we have some the distance that we are measuring uh, is already known. Okay, so if there is like what you have measured and what is the true value, if there is some differences between those two values, so that the difference is known as error. Okay, so that is the absolute error. Then if you want to calculate the relative error, then the percentage error, the formulas are on the screen. So it is very like very basic term that you need to know before building or making any system. Okay, so when you build your own system, then you have to check for its accuracy, and what kind of error it is producing. If the error is more, then you have to rectify the errors, and make your instrument more accurate, right? So if your instrument, like here, what is said, it is a sensor. So if you are giving a constant input to that sensor, and it is giving you same output over a long period of time, then we'll say that the sensor is categorized as a stable sensor, or this property is known as the stability of the sensor. Resolution I will be discussing in subsequent slide. So the fourth question is on your screen again. So the ratio of change of output value of a sensor to per unit change in input value that causes output change is called. What is it? Is it sensitivity? Is it resolution? Is it stability? Or is it precision? Okay, so answers are deviation from, okay, so B, Prince is saying A, Rajesh A, Sudeep A. Okay, so yes, it is a sensitivity is the answer. So I think you guys are learning effectively from the course, so that you are giving the correct answers. The question says the ratio of change of output value of a sensor. So in what ratio the output value is changing per unit change in the input value, that input you are giving to the sensor. So because of that input, the output is changing. So if we calculate the ratio, so that ratio is called the sensitivity of the equipment, or sensitivity of the sensor in this particular case, right? So fifth question is on your screen now. The question is the effect of factors such as backlash of gear, Coulomb friction, and elasticity of material may cause which type of error in transducers. So transducer are type of equipments. So which if there is the factors such as backlash of gear, or Coulomb friction, or elasticity of material is there. So what type of error it is? Okay, so again, A is the answer. Okay, so yes, hysteresis is the this type of error is known as hysteresis error. So what is hysteresis error? So here on the screen you can see there's a graph. Okay, so this shows the hysteresis loss. So once you so this is a this is a graph between this sensor output and the pressure. So if you are increasing the pressure, so you will see that. So if you're increasing the pressure, if you're increasing the pressure from this 0.2, you're going to the maximum point. Okay, and then again you are coming back. So you'll see there is some differences at although the starting point and end points are same, but in between, if you want to calculate or if you want to get the sensor output at particular pressure. So suppose this is the particular reference pressure point, and if you are calculating the sensor output at during the when you are loading it, and when you are increasing the pressure, and when you are decreasing the pressure, the value of the reference value, the pressure value is same, but the sensor output is different. So this is the error. Okay, so this amount is the difference amount, right? When you are increasing the pressure from starting to a top point, and then again you are decreasing the pressure back to the starting point. So this kind of error is observed in the system, and this kind of error is noted as hysteresis. Hope you all understand the concept. Sound is very low. Is it?
Yes, sir.
My sound is low?
No, sir. It's correct.
Okay, okay. Yeah. So, Prince, kindly check your. Is it fine now, Prince Kumar? I hope I am audible, Prince.
Yes, sir. You are audible, sir.
Okay,
Not a
okay,
problem.
okay. Thank you, Rajesh. So, so this was this is like what is called the hysteresis error, right? Now, moving towards the next question. Question number 6 is on the screen. Question says the product life cycle activities that related to the philosophy, functionality, and uniqueness of the product design is called.
Synthesis.
Okay, so I just do twice. So it is. Answer is some D, Rajesh, Sudeep. Okay, so yes, this is a synthesis. This is a part of synthesis, which is like when we are designing the product. So if we are considering the factors like philosophy, functionality, or uniqueness of the product design, so it comes under the synthesis. The next question, it is a very easy question. We have already discussed in the previous, I think in first session, this type of question we have discussed. So it is the study of motion of a system without directly considering the force affecting the motion is carried out in which discipline of mechanical engineering? Okay. A is the answer. Yes. So lots of people are saying A. Yes. So it is the kinematics. So if we consider the force, then what? Then what will be the answer? Uh, so in kinematics, we are studying the motion without directly considering the force, right? But if we are considering the force, then what will be the answer? Dynamic. No. Anyone else?
Sir, I think it's kinetics.
Yes. So in kinetics, we are considering about the force, energy, and mass. Actually, mass is introduced in the system, and once mass came, so that mass with the introduction of that mass, the force and energy is also induced in the system, and that kind of study is deal under the kinetics discipline. So people are still joining. So I request you all, like the late joinees, please join the session, like next session on time, so that you can get more things. So yeah, moving towards next question. Question number 8 is on the screen. The sheet metal rolling is an example of which type of forming process? Sheet metal rolling is an example of which type of forming process? It is advanced forming process. Is it primary? Is it secondary? Or is it tertiary? Okay, Prince Kumar is saying A. Then one answer is B. Anyone else want to answer this question? Is it advanced? Sheet metal rolling is advanced process or primary process, secondary process, or tertiary process? Okay, so I just say this is a primary process because it is the sheet metal rolling. What is sheet metal rolling actually? So when the materials, when the this metal ores are processed, okay, so then they are melted, and then there's a slabs are formed. Okay, so from the slab, once with the help of this sheet metal rolling, those slabs are converted into the thin sheets. Okay, so that is the very primary forming process, right? That forming process is the primary forming process. From those sheets, when we apply some other sheet metal operations, okay, to build the required component, then it comes to the secondary, tertiary, or advanced level. Okay, so I am showing you the a video of a roll forming. Okay, and in this video it has shown like how beautifully a sheet can be rolled into a required type of a structure, and how this certain kind of structure that you have, that you usually see around yourself, we usually see around ourselves, are built using this sheet metal forming operation. Okay, so kindly have a look over this video. So this is a roll forming actually. So the flat sheet goes inside the set of rollers, and this kind of structure you must have seen. So these structures are made up of this rolling operation. So here initially with the help of computer aided manufacturing this softwares, though how and from where we have to bend the sheet, or what kind of where we have to apply the force, at what angle we want our rollers. Okay, so all are set, and then we just supply the flat sheet inside into the system, and the output, as the output we get the desired component. Okay, so this is the beauty of what I can say, computer aided manufacturing, and the combination of that CAD with the manufacturing system. So yeah, this kind of structure, like it is visualizing different kind of structure, and if we put like what angle should be there between two sides of the component, and then we have to, this rules are set automatically set at, and then you will see like the worker is just giving a flat sheet inside the system and getting a like desired component, right? So hope you have got the idea of like how this certain kind of components are built through uh, uh, this sheet metal rolling operation. Now, next question is on the screen. The question is, expandable molds are used in which type of casting process? Expandable molds are used in which type of casting process? So T. Sankar Lal says A. Again, one answer is A. Sudeep Chaudhary A. Okay, Rajesh A. Okay. Yes, so expandable molds are used in green or dry sand mold. Okay, so this is a very basic casting operation that you must have done in your first year of your graduation course. Okay, so when you go to the this foundry shop, so in the basic basic workshop course that you all have like must gone. Okay, so there they, with the help of sand, we just make some molds. Okay, so those kind of molds are expandable mounts. So can somebody says like what is permanent mold, and like in which type of casting process we use permanent molds? Anyone? In which
Sir, I
kind of
think option C, sir,
die?
dye
Yes.
molding.
So yeah. So die molding or die casting is a permanent is a type of casting operation where we use permanent molds. Okay. So that molds are maybe made up of hard material, maybe metal or something like that. Every time we can use the same molds. In the expandable molds, we this is used for like single one time use. Okay. So we make for a component, we pour the molten metal inside it, and once it is solidified, we broke the this molds. Okay. So there's a second option, b is the investment casting. So can do you know what is investment casting? Anyone in the class? What is investment casting? Wax pattern. Okay. Yeah. So just here is an example, a beautiful example of like how this investment casting is used to make the product. Okay. So yeah, so first of all, we used to like make a box, and where we used to inject the wax. Okay. So this kind of structure we want, this is the structure that we want. Okay. So we'll prepare a wax pattern of this kind of structure. Okay. So we use investment casting for producing like more number of component, same type of component. So this kind of this kind of wax patterns are then attached into a like tree kind of a structure, or a gate that is having gating system and feeding system. Okay. So this whole is made up of wax. Okay. This whole component, this assembly you can say, is made up of wax. Then this wax pattern is dipped into the slurry. Okay. And a coat of slurry is like deposited here over the this wax. Okay. Wax surfaces. So there's a like 5 to 10 mm thick this slurry is deposited over this, and the complete assembly look like this. So after deposition of this slurry, we again what we'll do, we keep this slurry into some like to heat it through some like it may be some autoclave or furnace. Okay. So that this wax, the wax that is inside it, melt and comes out. Okay. So once the wax get melted and out from this system, so there is a hollow cavity, right? So in that hollow cavity, we pour the molten metal. Okay. So as like we pour the molten metal inside it, and once the metal is solidified, we break the ceramic cell, and then we get the component, and when then we apply some final processing or polishing operation to get the final product. Okay. So hope you all have all now know what is investment casting and what is the purpose of this investment casting.
Sir, and on one thing, sir,
Yes.
can I explain progressive mold casting, please?
Okay. Okay. Yeah. Hello.
Yes, sir. I need information of progressive molding, sir.
Okay. Okay. You want the information about the progressive mold casting, right?
Yes, sir.
Okay. So we'll take this question in the like last after completing this section. Okay. Right.
Yes, sir. Yes, sir.
Okay. So moving towards the next question. There's the last question for this section. So next question is on the screen, right? So soldering is an example of which type of welding process? So options are autogeneous, homogeneous, heterogeneous. C. Okay. So people are saying C. Yes. So it is a heterogeneous type of welding. So why it is heterogeneous type of welding? So like welding can be defined, welding can be what you can say categorized into two types of into two types. So one is with the help of filler in the welding, where we use filler, and another is where that is without filler, right? So if with filler, so there are two kind of things. If the filler is of same material, which material which that we are welding or that we are joining, okay, so if the metal properties are same, so it is known as homogeneous, right? And if there is different material, the base material is different and the filler material is different, so it is termed as heterogeneous. Okay, so here we are talking about soldering. So if you have seen the soldering operation, there is a copper wire. Okay, so that copper wire is used as a filler to join two different kind of component. So that component may be of different material. So if these component are different material, and then we are pouring some copper, so it comes under this heterogeneous type of welding. Now there is another category of welding where we don't use any we do not require to use any kind of filler. So those kind of welding operations are termed as autogeneous welding operations, right? Hope you all get the answer. So similar kind of query was there in the discussion forum also. So that's why I just explained it. Now, so this is all 10 questions from my side. Now I'm going to take the questions from the discussion forum that is already there on the discussion forum. Okay, so there's the first question. It is saying, what is the mechanism in a smart watch? Okay, although we have the mechanism of watch we have discussed, mechanical watch in the very first session, and this content was in the week 1, but I took this. Okay, so this is the answer that is also mentioned in the portal. It says that according to the question, I believe that you are asking specifically about the mechanism about the time display. Basically, smart watches are connected devices, be it through wireless source or any LTE source. These sources help synchronize the time of the watch with local time. Okay, so this is the answer that is already posted there. So I'm just showing you the mechanism, or you can say the components that are there in the smartwatch. Okay, so in any smartwatch that we have, there is a microcontroller unit. Okay, and it is powered, it is like powered with some DC source, or maybe we use to charge it like you through USB. Okay, so with the charger, with charges, there is a power management IC unit that stores the power and then supplied the power to the microcontroller. Right, now these microcontrollers are what you can say are the host for several kind of sensors. So like there is a pulse sensor, there is temperature sensor, accelerometer, then in some advanced watches there is some camera interface also. Okay, now then there is a vibration signal. Sorry, so there is a lot more of more type of sensors are there. So with the advancement in the technology, there are lots of sensors that are induced on the this control unit of the smartwatch. Okay, now there is a display. Okay, on the display where we can interact. Okay, that is definitely a touch display. We can give input and get the output there. Okay, then there is like vibration is also there. So if the smartwatch want to give us some alarm, okay, or some reminder that we have already fixed. Okay, so at that time it vibrates also. So there is some component that vibrates, and we feel the vibration. Okay, and then there is some flash memory. Okay, so this flash memory are used to store the kind of instruction. Like suppose we are doing our workout. Okay, so we start the time timer for the workout. So at the end of the workout, we see the summary, right? So summary in terms of like what is our breath rate, or heart rate, or what time up to what time we have done the exercise, what was the speed, what was the average speed, and all these things. So all this information is stored in the flash memory. Okay, so this is the complete what you can say components, list of components of in any smartwatch. Okay, and as it says, like for time control, so usually all the smartwatches we connect with the help of like mostly with our mobile phone or cellular network, and then some are maybe connected through some wireless sources. So with that and with the help of GPS, so it automatically say it is in synchronous with the local time of the place that where we are using that smartwatch, right? So I hope this the working and the what is the smartwatch, what is the mechanism of smartwatch, it is clear now. Is there any question on that?
No, sir.
Okay, thank you. So moving towards the next question. So next question was the fourth dimension in manufacturing. So it says like how it is possible to create the fourth axis among X, Y, Z, how it helped to manufacture it easily. Okay, so in the video at this particular point of time, like multi-axis CNC machines were shown. Okay, so he's asking like how it is, how the fourth axis is there and how it helps in the manufacturing. So yeah, so this is the answer that is mentioned on the portal itself. The answer says the cutting tool will be moved in translation as well as rotation axis, so that we can get more than 3 axes. Okay, so the 3 axes like movement in X, Y, and Z, and then there is a rotation of the cutting tool, then there is a translation of cutting tool, so that induce another axis or gives another degree of freedom to the machine. So here I am going to show you a 4-axis CNC machine. Okay, and so you can see that there's a video of a 4-axis CNC machine and how it is operating. Okay, so your tool is already having XYZ motion, and then this workpiece check is the check that where the workpiece was mounted is also rotating. So it is giving the fourth axis to it. Here you can see the bed or the bed where these workpiece is mounted, it is rotating and then it is translating also. Okay, so that introduce another axis in the into the system and another degree of freedom to the machine for manufacturing or for machining of the complicated kind of structure. Okay, or complex kind of structure. So this is now very these are very popular now. This kind of machines are very popular now. So people want more degrees of freedom in the any of the CNC machine. Okay, so that a single machine can be used for performing several kind of operation. Okay, in a one mounting of the workpiece. So it saves time, and also it gives us like accurate product as desired, right? So this is the four axis machine. Now I have also a video of 6-axis machine. So this is the huge machine which is having 6 axis. Okay, so so this is a video. Here you can see like how it is, how the tool post itself it is rotating and performing the cutting operation or machining operation there, right? So how a workpiece that is having some inclination, declination, and some so how it can be machined. So with the help of this 6-axis CNC machine, we can easily machine such kind of components. So I hope some of you must have seen this in your workshop, or if you haven't seen, so for that purpose I have just shown this here. So now you have got the idea like how the CNC machines with more than 3 axis work, and how why they are very important, and how they make the job easier, and they are very like very fast in sense of processing also. So I hope you like the video and get some information from that. Anyone want to ask any question from this slide?
No, sir.
Okay. So have you ever seen like this kind of machining operation in a real like
No,
in
sir.
real
We
scenario?
have only seen in CNC machine with
Okay.
has 3 axis only, sir.
Okay.
So
Okay.
that's
Yeah.
why we
So yeah,
have seen.
typically like typically in the institutes or the academic institute, that 3-axis CNC machines are there. But once you go to some industrial shop floor, you will definitely see nowadays there are this kind of machines are there. Okay. So moving towards next slide. So in the next question that is asked on the discussion forum was like in the tool room and in the manufacturing factories for inspection of size of semi-finished or finished component, which kind of tools are used? So I think this is a question from some assignment or something like that, but I want to discuss it here. So yeah, can somebody answer this question? Like for inspection of size of semi-finished or finished product, which instrument do you use prefer, or what instruments are preferred for inspection of size of semi-finished or finished components?
Dolly, sir.
Dolly.
Is it correct, sir?
Dolly, what is dolly? Anyone else? For measuring the like if like there is some workpiece, okay, so suppose there is a workpiece and it is semi finished, like only facing operation has been performed. Now you want to measure the size of the semi finished component, like that you have just performed the face milling operation. Now after face milling operation you are going to perform the end milling operation to reduce its size from the like one of the end. Okay, so what kind of instrument that operator use on the workshop, in the workshop or on the manufacturing shop floor? You must have seen, I think it's a very simple thing. Anyone? So whatever you coming into mind, kindly answer, right? There is nothing if the answer is wrong or something like that. Sunil, Sachin, Charan, Amritpal, Ajay, anyone? No one want to answer. Okay, so yes, this answer came CMM, right? So we'll discuss this CMM. Anyone else? Any other option?
Sir, it's automated storage and retrieval system, sir.
Oh no. Where are you going? Like automated storage and retrieval system is for what? For carrying the component, for storing those components, storing the inventory, storing the semi-finished component and then finished components. Okay, it is storage kind of thing. Here, what I'm asking what is the instrument that is used for inspection, right? Do you know inspection? Like if suppose if this is the workpiece, right? This is the workpiece. So if I have performed some, suppose one of the operation, any machining operation that comes to your mind. So I have performed this, right? I have performed one of the operation here. Now I want to measure the dimension of this. So what we use if I want to inspect the size of this component? Don't disappoint me. If you this, so suppose you have a bottle. If you want to measure the dimension or size of that bottle at your home, that this drinking water you already have. So if you want to measure the size of this bottle, what instrument you will use? Coordinate measuring machine, perthometer,
I like the
digital Vernier. Okay, so spectrometer and digital. Okay, so yeah, let me show you some of the instrument that you may have seen. This, is it visible?
No, sir, it's not visible.
It is not visible.
Yes, sir. It is Vernier Caliper. No?
Yeah, it is Vernier caliper. So you have seen this Vernier caliper or not?
Yes, sir. We have seen it.
Huh?
In a
So
physics lab, yeah.
why we use this Vernier caliper? Why we use this Vernier caliper? So suppose this is a bottle. Okay, we are like, suppose this is a shaft. Okay, and we want to measure the diameter of this shaft. So we use this Vernier, right? Is it or not? Is it or not?
Sir, are you showing any pictures to us?
It is not visible. Let me. So Purananda Patra, kindly unmute yourself. Purananda Patra. Hello. Okay, some random guy is there. So yeah, I was showing you some instrument. Let me. Okay. Okay, so is it now visible in my video?
Yes, sir.
Huh? Is it visible or not? This instrument that I'm showing in the video.
Yes, sir. It's visible, sir.
Okay, so this is the what you can say Vernier caliper, right? So this Vernier caliper is used for measurement of some cylindrical diameter or something like that, or you can also use it for measuring the dimension of this kind of component. Okay, rectangular component, right? So with the help of this, there are reading, and then this kind of component you must have studied with very details, because with the help of this Vernier only the first step of the metrology is started, right? So moving towards the answer that I have, so these are the equipment that you have seen in your maybe in your workshop, in your laboratory, okay, that are used for measurement of the semi-finished or finished component or different kind of components, right? Have you seen?
Yes,
Yes,
sir.
sir.
Okay, so these are different kind of components. If you haven't seen, just see it. Okay, have a look over it. It must be there in your respective laboratory. Okay, in whatever institute you are, this kind of instruments are must, like these are the very basic instrument, and these are there. Okay, so there are different instruments. Now moving towards the metrology room, it is written that tool rooms. Okay, so this here it is written like tool rooms or metrology rooms. So in metrology rooms we have, or some of you may have seen, because I got the answer here. So someone says that CMM. Okay, so this is the CMM, right? Sunil Goyal, P. Sankar Lal said that CMM. So this is a CMM. So it's a C, like it is based on the kindly mute yourself, those who is Bhagwat, kindly mute yourself. Okay, so this is the CMM. Okay, so what is the working of this CMM? Anyone? Like two people have said like CMM, so I want the answer from you guys. Can you explain? Sunil or T. Sankar Lal? How CMM work? Okay, so we are running out of time. I will discuss it. So CMM, like the full form of CMM is coordinate measuring machine. Coordinate measuring machine. So what it does? So suppose there is a component. Okay, so suppose this is the component. Okay, so there is a probe there. Touch probe is there. That probe comes and touch the surface of this component. Okay, and the point of like touch or the intersection, or where it is touching the component, that point the machine capture, okay, in terms of x, y, and z. Okay, so suppose if I give you 2 points, point 1 and point 2, in terms of coordinates like x1, y1, z1, and x2, y2, z2, are you able to interpret something from these 2 points? Will you able to get something from these 2 points? Any formula or anything that you have studied in class 11th, like if you have two coordinate point, then you will able to get something, some feature. A straight line formula, something you're remembering? Anyone? If suppose suppose this is point P1, right? I'm giving this point P1, and then this is point P2, right? And here is the value of like x1, y1, sorry, x2, y2, z2, and here it is x1, y1, z1. So can somebody give me the distance from this point to this point using some mathematical formula? This we have already studied in class 11th. Anyone? Hello, am I audible? Hello.
Yes, sir, you are audible.
Okay, so so you're not able to recall that formula, right? But you have studied. Are you able to recall that you have studied this kind of thing
Yes, sir.
in mathematics in class 11th mathematics itself, like where you have studied about the this equation of the circle in terms of x and y, and h and k was there, and maybe r was there. So this kind of uh, formula you have already maybe you have studied in class 11th, if you recall. So okay, leave it, no problem. You just have you can just recall it, okay, whenever you have time. So this cmm, like how would this cmm work? So this cmm collect the point, okay, point in terms of like this x1 y1 z1 x2 y2 z2, and then lots of points are there. Okay, the like suppose this is a surface, some surface is there, so there is at the surface it captures the different points, okay, so different coordinates it's captured, and then it processes the coordinates with the help of this mathematical relation that we have already studied, and then we get the desired feature. If I want if I want the distance from this point to this point, so with the help of these number of coordinates, I just apply the mathematical formula and get the length. So this application of this mathematical formula and the calculation, it is performed in the this control unit or the processing unit of this machine itself. So it displays the directly the size of this or the length of this from this point to this point. Okay, so this cmm are nowadays are very what you can say, these are the costlier machine and very precise, okay, and they are very capable. So if you have some component, okay, so if you use cmm to measure the coordinate, so it can also build a 3D model of that component for you, okay, with the help of this cloud point data, this coordinates. Okay, so if there's a lot of point, so we call it a cloud point data. Okay, so with the help of this cloud point data, this cmm used to build first of all it will build a 2D model for you. So from there it will tell you the size of the required feature, okay, and then you can build there are software that can build the 3D model for that particular component also. Okay, so this technology is in existence like since long time. Recently a new kind of machine has been came into the market, in the commercial market. Okay, so that is based on camera. So this is a vision based dimension measurement system. Okay, so what it does, it captures the picture, okay, picture of the component, and from the picture, suppose this is the picture, it has been captured, and I want the dimension of this particular rectangular component. So it process, and with the help of image only, it process it and then gives the dimension of this particular feature in the image. So this is a very advanced technique, and there are like lots of advantages of using this vision based system over this cmm. Okay, so I hope you got some idea about what kind of instruments are there in the metrology room for the measurement of inspection, or for the measurement of size of semi-finished or finished product, right? Anyone having any question, any doubt? Rajesh, yes.
Sir, I think, sir, I have posted on question, sir. It's a revolution.
Revolution.
It's one of the sensor characteristics, sir.
Distance between them by coordinate, yes, x square plus y will reduce square. So like where you posted that question?
And I think it's below from the video, sir. Ask question. It might be notable in discussion form, sir.
Okay. So I will see. Maybe I have to put that question in next slide. Okay. So
Okay, sir.
in this slide, is there any problem? Like, is there any, like, hope you got the things like what kind of instruments are there in the metrology room? These are the very precise components. Okay, so, so only I hope only, like, if you have seen this kind of machine, so you are very what you can say, you have gained something more, much more information, because these are very what you can say, very few machines are there in the academic this institutes. Okay, so there is a scarcity of this kind of machines, and these are the very advanced machine. So these both machines are there in IIT Jodhpur, in my lab only. This kind of machines are very critical. Okay, so these are used for this inspection of size of the components, right?
Okay,
So
sir.
moving towards next question. Okay, so this is a question, right?
Yes, sir.
Okay. Okay. So yeah. So as I said, key resolution we'll discuss in later. So yeah, I'm going to discuss the resolution. Okay. So
Okay, sir.
about resolution. So resolution is like, as per the definition of resolution, resolution is the smallest increment an instrument can detect and display. Okay. So what it means. So suppose you have seen this multimeter. This multimeter.
Yes, sir.
Okay, or not this multimeter, you must have some thermometer. Okay, suppose this is a thermometer display, right? So
Yes,
this
sir.
is showing like 15.00 something, maybe millivolt, or leave it, volt. Okay, so what will be the resolution of this system? If someone asks what is the resolution of this system which is giving the output like this? Okay, so it means that the smallest value that it can show, or that it can detect, this instrument can detect. Okay, so this is the instrument, this is showing this this particular output, okay, by sensing something. Okay, so this is a multimeter, it can sense the voltage and current. Okay, so suppose it is showing the value of voltage in this kind of digit. Okay, so the minimum value that minimum next value that will appear here will be like 15.01 volt, right?
Yes, sir.
Okay, or if the value is decreased, so it will be like 14.99 volt, right? So this is the like 0.0101. This is the resolution of the system that is showing this kind of display, right? Have you got what is
Yes,
the
sir.
resolution? So
It
like,
means least value of the
least value that an instrument is showing, or that an instrument is detecting and presenting the result, right? So suppose this is a system, right? This is some system. Yeah. So suppose this is a system, right? You will apply some input, and then you will get some output, right? Is it or not?
yes, sir.
So this is the output. This is the output, and the input is in term of like voltage, right? So if you are applying some unknown voltage and you are getting some value of like 15.00 volt. Okay, so if you increase some voltage again, okay, which some voltage you have increased, so you got the value like 15.01 volt, right? Again you increased some value, you got 15.02 volt. Okay, so from like, then this system, what will be the resolution of this particular system? What you'll say?
0.01, sir.
0.01 volt, because it is detecting only this much amount. Okay, it will not able to detect like 0.001, right? This is in this is not able, this system is not able to detect this increment or give this increment, right? So suppose for suppose this is v1 value, and then plus 1 you are doing, to v1 plus 1 you are doing, and you are getting like, for v1 you are getting this, v1 plus 1 you are getting this. Okay, so you can say that the resolution of the system is 0.01 volt. Okay, so this resolution changes as the you use precise components, more precise component to build the instrument. Okay, so this resolution changes, so it can detect like from like hundreds of the division to the thousands of the division, and then to the millionth of the division, right? So in your hand you maybe have some scale, measuring scale is there, scale hogi na, there is some scale. So
Okay, sir.
in this scale, what is the minimum value, what is the resolution of this scale, measuring scale? Let's-
0.1 mm, sir.
1 mm, right?
Yes, sir.
Are you right? 1 mm you are saying, 0.1 mm you are saying.
0.1
Just
centimeter.
think one more, think one more.
Oh, sorry, sir. I think
So this,
1 mm.
yes. So 1 mm is the 1 mm, the like this is the scale, right? Here.
Yes,
So
sir.
what is the minimum quantity that you are able to measure here? That is 1 mm, right? So
1 mm, sir.
so one, if you want to measure 0.5 mm, will you able to measure with this? No,
No, sir.
you will not get the value. So you have to use
No, sir.
some other precise component. So you will use this vernier, right? So this is the physical instrument, but that are like that do not require any input or output kind of thing. So here, if a system is there, in terms of system we are talking, same thing applies to here also. So here is the system. What you can say, this is a multimeter, or I said there will be some thermometer, okay, at your home, or you must have seen some thermometer, and some readings are there. Okay, some markings are there. So once you increase the temperature, okay, once you increase like this is the tip of that. So if once you this tip is getting heated, okay, through any mean, like if you put into the boiling water or some warm water, so it will start showing some reading to you, right? So in today's era there are digital thermometer. So they used to so in
To measure our body temperature,
yeah,
sir.
body temperature, yeah, right. So it will show something like that, 99.0 Fahrenheit, right? Something like that. It shows the thermometer that you have used. Okay, so it will not be able to give the value, like if there is change in like this much amount. It will not able to detect this much amount, 0.09 Fahrenheit. It will not able to.
Yes, sir.
It will show like 0.1. So this 0.1 will be the resolution of this that particular thermometer, right? So here
Yes, sir. Yes, sir.
there are different examples. So if like this is the two value like 1.2 volt. So it means the resolution is of like 0.1 volt of the system, right? This kind of, if there is a display of this kind, so it will be this. So if you see this kind of display, it means it will be able to measure the 0.001. Okay, and again here 0.001. So you can see how this resolution is moving from 10th to 100 to the thousands thousands of the value, right? So here range versus resolution, some table is there. Okay, so here like it is like showing that millivolt, and after decibel it is 0.1. Okay, so 0.1 millivolt it will be the resolution of this particular instrument which is measuring this, right? So Rajesh, I hope this confusion of resolution is now resolved.
Yes, sir. Yes, sir. So it is the capacity can show the least count value.
Yeah. Okay,
Yes, sir.
so
That's it, sir.
the least value or least increment that any instrument will display on application of some input. Okay, so if there is
Okay,
some
sir. Okay,
sensor,
sir.
so it takes some input, right? You give some input thing. It may be in terms of voltage, current, temperature, force, anything. Okay, and once that from that system the output will come. So that output will be in term of something that is desired. So for this thermometer, it is in terms of degrees Celsius, degree Fahrenheit, something like that. For like if this is something weight measuring, what you can say, weight scale, so that will be in terms of kg, grams, like this. Okay, so you are applying some force and you are getting some values here. You are applying some heat or some temperature, so you are getting these values here. Okay, so that instrument, the instrument that can measure or sense the smallest increment, okay, and shows that value. So that smallest increment that it is displaying is the resolution of that particular system, right? That change in the input that it is recording,
Okay, sir.
right? Okay.
Yes, sir.
So Thank you very much. Now I'm going for the next question. Okay, so next question was asked in the last session. Okay, someone has asked like what are the sensors that are there in the fire alarm or smoke detector. So we have turned out with like there may be some sensor of like gas sensor or maybe some thermal sensor. Okay, so here I just searched about that and I got a very beautiful clip here, so that it can help you to enrich your knowledge in terms of like what how this fire alarm system works. So there is a photoelectric detector. Okay, so these laser rays are like incidenting on the particular surface, and once this what you can say smoke goes inside it, so this the rays get deflected. Okay, and the receiver is not able to receive those rays, so it will sense the alarm. Another is ionization detection. So in ionization detection, though since there is a difference between the ions that is produced during the smoke, so due to that difference, the circuit get breaks, and then this fire alarm start fire alarm starts sense this smoke and give us the alarm, right? So this is how this fire alarm or smoke detector work, right? Okay, so one more thing is left, but we are running out of the time. I will see that and I will try to discuss it in next class. That progressive casting that you have asked anyone, someone has asked this. So yeah, we are running out of time, so we have to close this session. Okay, so we are going to celebrate our Independence Day on 15th of August. So wish you all a very happy Independence Day. So we are celebrating. We are already celebrating the Azadi Ka Amrit Mahotsav, and flags we have already hosted in our homes. Okay, so uh, I just wish you very happy Independence to you all. Thank you very much. So if there is any query, you can post, and I will take those queries in next session. Otherwise, you are free to leave the session. Thank you very much.
Thank you, sir.
Okay, so there's no question. Thank you very much. I'm stopping.